45th Salon of Architecture. We're continuing with discussions in a panel. This evening we have a guest, Ben Beer, coming straight from Dubai, Werner Sobek's office in Dubai. And we'll be talking about latest development in the facades, some crazy architecture wills that Ben turns into feasible buildings. And something that's very interesting to me, that is this human-centric approach to buildings and putting a man in the center rather than nature. So Ben, thank you for coming to Belgrade and bringing this discussion to high level of this salon.
Thanks for the introduction, and thanks that I can be over here. I think I will start straight away into the presentation. So I'm Benjamin Beer, or Ben Beer. I'm working for Werner Sobek. And today I want to explain a little bit about modern architecture, how we see it, what kind of project we're working on, and also a bit about the kind of scientific background on where we came from and where do we want to go in terms of technology and design, and also how can we focus a bit more on us as a human being. So just a quick introduction. I'm working for Werner Sobek. We are a global engineering office with about 350 people worldwide. These are the kind of offices and projects around the world. And talking about, because this is currently, a lot of architects are driving to this kind of sustainable design, a kind of green architecture, green design. Now looking at this building, it's so green, it disappears almost within the green nature. So is sustainable design something new that just our generation of architects and designers invented? It's not. I mean, this building was built about 300 years ago. And it's a question, can we learn from the past? You know, in the past, and it's quite important to understand, because in the past, people had limited resources, limited technology, but what they did with it, and quite often they were forced to do it, but maybe we can learn a bit about for our nowadays design. Now, this building is still there. It survived over like 300, maybe 400 years. And if you look into the kind of specification, this is what we nowadays have quite often as a facade consultant. We have specifications, a kind of technical description of the system. And if you look at this facade design and talk about this kind of specific facade that was built about 400 years ago, you see it's a double skin window, which is super modern. There's operable natural ventilation, also super modern. It has operable external shading by these green flaps. You can open, close, and you can achieve varying degrees of shading. You can adjust your U value because you have 2 layers of single glazing, so actually the U value can be adjusted by opening 1 or only 2. You have low maintenance. It's relatively simple technology. It is environmentally responsive. It's all made of wood and simple glass. Almost a full recyclability, at least of the metal parts, and biodegradable in terms of the wood. So if you put this specification down for a modern facade system, a lot of contractors would fail. Yeah. So it's a bit of question, can we pick things? Can we learn from the past? And also looking into the kind of CO2 emissions from such a building. Usually they had a kind of barn, or they had animals. Usually the animals were in the basement or ground floor. Then the living rooms or the bedrooms were above. Yeah. So the heat from the animals, from the cows, pigs, whatever they had, it was going up. So it was natural heating. So they were very smart in positioning. Where's the barn, where the people are? Now this whole building was run with one single stove in the center. So people were sitting around, maybe this laser thing goes here, were sitting around the stove. So they just had one fire heating up, or I mean, more or less heating up. I mean, still not the thermal comfort that we would have nowadays. But this building was so environmentally friendly, I think nowadays we would struggle achieving that. So it's and going from kind of cold climates like Central Europe, going to hot climates. What did people do there in the past? And very similar approaches. It was about understanding nature, understanding physics. What can we do to enhance the thermal comfort of human beings? And this is quite a key also for nowadays, actually for our design. If we want to make things better, we need to understand how the human being works. And this is the example of the traditional wind towers that were built in the Middle East. So during the summer, it is extremely hot. So you're trying to harvest the wind. So you're collecting the wind from a higher altitude, you're getting it down, and then going into the kind of traditional aerobic courtyard. And then this wind flow making it at least a little bit more comfortable in terms of thermal comfort of the people. So low tech built centuries ago. Then also about shading, they didn't have glass in the past, so they did this kind of so-called mashrabiyah screens. So the mashrabiyah screens provided privacy and let air going through the screen. So also continue this kind of idea of wind flow. Then in the old Arabic cities, the buildings were built very close next to each other, so the pathways were shaded. It's about shading. So it's also showing that people in the past had an understanding how they can make the world a more comfortable environment. And this is a very nice graph that I like to see. It's shortly about kind of during the Second World War in the United States, they did some experiments about thermal comfort of human beings. And this graph also a bit of throws me back, when I was doing presentations, for example, in Saudi Arabia, about sustainability. There were some old local people from Saudi Arabia standing up and saying, oh, this sustainability, air conditioning is all modern. We didn't have it in the past. So people survived without air conditioning in hot climates in the past. How did it work? Yeah. Nowadays, people would complain immediately. And this kind of graph shows people were put by the US Army into a kind of climate chamber, kind of big room, and the room was actually heated up. Yeah. So you can see on the left-hand side, this is kind of skin temperature and the heart rate. And then there you see the days of exposure. Yeah, and you can see that the first 4 to 6 days, people were stressed out. So the heart rate was high, you were sweating. But then human beings are able to acclimatize. So your human body acclimatized to high temperatures. The same also for cold temperatures. Yeah. So this is how the people survived in the past. Because you just have to pass through 4 to 6 days, and then your thermal comfort is getting better. But nowadays, people are no longer willing to do it. Yeah, people are sweating immediately. Air conditioning in your car. You drive your car. Oh, it's hot. Air conditioning. It's too cold. Switch the heating on. Yeah. So people in the past were more willing or were more used to withstand heat or cold. And this is quite important to understand. So we as a human being, we could go back, yeah, to these kind of designs, but do we want to? This is another question, a bit more kind of about our society. Okay, now taking the steps further, learning from the old traditions. This is a project in Riyadh that we just finished the design on. In Saudi Arabia, we see a lot of movements nowadays. They're building a lot of new houses, new cities, because the population is quickly growing. Now, in these hot climates, we try to achieve a more comfortable outdoor climate. And this design involves a huge shading canopy with integrated wind towers to create an outdoor thermal comfort so that people can walk along the streets, even in the summer, more or less comfortable. You can see this whole design, so there's a complete new kind of city or kind of half of a city that's built. And between the buildings, between all of the retail shops, houses, and so on, we want to go away from this car society, because currently in the Middle East, everybody's driving a car because it's hot. But if we achieve that, we're getting the buildings closer again, so that you don't need cars. And then people are able to walk outdoors in a thermal environment that is comfortable, even in the summer, with less sweating, then we achieved quite a lot. So this design, you can see, involves wind towers, which are kind of cantilevering out from ground. They're getting wider at the top. They're collecting the wind from the two main wind directions and funnel this wind down. At the same time, we have this kind of shading canopy to provide shading. In terms of design, we designed this kind of big kind of wood shell structure between the buildings, supported on the buildings. Going actually to the next slide, it shows a bit of the kind of technical complexity behind these kind of things. If we do design nowadays, especially for the so-called freeform structures or these kind of shapes, we optimize them, first of all, architecturally. Of course, the architect has to say how the geometry looks like. But then we also say we want to build ideal kind of wood shell structure, ideal arches. So we then modify the geometry for structurally more optimized geometry. All of this is run in parametric scripts, so we're fully working in Grasshopper with Rhino, because otherwise these kind of structures in 2D, you cannot design them. We call this kind of approach CAD, kind of CAD to CAM, so computer-aided design to computer-aided manufacturing. This involves that nowadays we even pass on the 3D models from the designers, from the architects, from the consultants to the contractor. Now, I was talking about the wind towers and what people in the past were able to assess by simple things, just putting the finger in the air and know the main wind direction is from this side, usually from the sea. Nowadays, we have to use so-called CFD analysis, which is computational fluid dynamics. So these wind towers have two openings, and we're then collecting the air from the main wind direction and funnel it down. You can see the red areas are the areas of high wind velocity. And on the right-hand side, you can see that the percentage of time when the exterior environment conditions are kind of acceptable to human beings. So we did certain studies, and we've seen with the help of a CFD consultant at which times, at which year we are enhancing the kind of outdoor thermal climate. I mean, you have to be realistic. You cannot achieve that the whole summer in the Middle East is getting nice with these kind of things, but we are actually enhancing it. In terms of design, as I said, we're doing the full 3D design. We designed the steel structure, the cladding panels, which are made of GRP. Even on the right-hand side, you can see inside this kind of wind towers, we have access ladders. So you need to go into all of this detail to get it built, to get it done, because you need to consider a lot of mechanical equipment, other equipment. Within these wind towers, you can see at the top right corner, there are, over here, it's not on the screen here, we even included fans, so in case there's no wind, there's no wind flow at ground floor. So we then included electrical fans to create artificial wind. So we're then blowing air down. At the same time, we have water spray systems included in these wind towers. So we use the so-called evaporative cooling. So we spray water mists into the airflow, and the natural effect of this evaporation cools the air down. Of course, it also slightly increases the humidity levels of the air, but it's working. So this kind of project shows a bit of the whole design. You can see in the middle, this is the MEP system of the air fans, of the air intake, of the air exhaust. We see on the top left corner, this is a kind of rotating drum. As I mentioned, we know two main wind directions. And of course, when the other direction comes, we have to rotate the drum. So this involves that we need to scratch our head because all of this is unique. No one built it before. And this is where usually we as Solarno-optičkih, we step in, we take on the challenge, we design these unique things. So we designed all of the mechanical parts, this rotating drum, the mechanical equipment, the steel structure, so that we were able to pass on the full design to a contractor to build it. Talking about the shading, as I mentioned, it's a shading structure. Usually our grid shells need to be lightweight because we're talking about big structural spans. So this grid shell has a span of over 60 meters, so 60 meter clear span. And we're realizing this clear span with a steel box section of 300 millimeter height. So the span to structural height ratio is amazing, but to achieve this, we need to be efficient. We need to be efficient, first of all, in terms of weight of the materials. And the most efficient materials are, of course, tensile structures. So we used fabric, so stretched fabrics, tensile cables to achieve the shading. At the same time, we optimized the geometry to achieve a perfect arc, which is already done by the Romans, yeah? Perfect arches. We then designed a so-called grid shell system with nodal points that take on all of the different angles, which are actually CNC machine. You can see it on the right-hand side. So on the right-hand side shows one of these typical nodal points of your grid shell structure. This then all bolted get together. These kind of systems, for us, it's a step forward. We're combining old design ideas with a very modern technology. Yeah, we're doing it in a bigger scale, and we're trying to enhance the kind of world. Yeah, make this world a better place to live for the people. If they want to walk out in May or June in the summer, it's still a nice climate, or more or less climate. We can sit outside. Talking about Middle East project, this actually brings me to my next project. We're currently the facade consultant on the Neom Chujina Vault project. A lot of you might know the Neom development in KSA. And Saudi Arabia is a fast developing country. The population is growing. This Neom Chujina Vault, it's a project in 2,000 meters height. And we're currently involved in this so-called, the Vault project. The Neom Chujina development is on top of the mountains. They were winning the Asian Winter Games, so they're going to do winter games in this area. They also have snow for certain days, so they have snow, it's cold, it's getting cold in there. The background is the following. This is intended as a kind of destination. As I mentioned, during the summer it's quite hot, but in 2,000 meters height, it's about 10 to 15 degrees less because of the height. So just starting by the location, you are achieving a better outer thermal comfort. You're also achieving that you require less cooling loads because you are 10, 15 degrees less than at sea level. Now the whole design as it is for the vault, it includes that we're building almost half of a city, half into a mountain. Now usually the mountains give some thermal mass. I mean, it's a bit similar if you're sitting into a very old building, like in an old church. The walls are like 2 meters thick. And during the summer, it still feels cold because you have a thermal mass of this big thermal mass. It's a bit of a similar approach over here that the mountains helps to cool down this interior space. Yeah. At the same time, we are doing a high degree of shading. And at the same time, we're doing kind of wow effect, which a lot of projects have. And you know, for the Middle East, and let's take Dubai as an example, Dubai, or this kind of modern Dubai started also with this kind of landmark projects. You know, if you look at the postcard from Dubai, it's usually the Burj Al Arab. This is what everybody knows. But you know, also, I mean, this is in the end not it is in the end not a new invention. Paris is the Eiffel Tower. New York, I mean, all of the cities have the landmark buildings. And this is the same how actually Dubai started with the Burj Al Arab, then the Burj Khalifa, the world's tallest tower. Everybody wants to go there, see it. So it's a bit of a similar maybe approach that you're designing landmark buildings or landmark architecture to develop cities or countries. Now coming back to Neom Chujina, the vault, this video file, I hope it works.
Journey to new heights, a unique global destination driven by cutting-edge technology in Neom. This is Trojena. Breathtaking architecture and innovative engineering fold seamlessly into the natural landscape, ascend to a vertical village, a portal connecting the digital and the physical. The seasonal climate provides a multitude of high-altitude adventures in the Arabian Peninsula, with the region's first outdoor ski experience. Enjoy the buzz of world-class entertainment, the crisp mountain air, and the world's most advanced health and well-being center nourish both body and soul. And as night falls, you can witness the stars as you've never seen them before. Welcome to Trojena.
Now, on
The
these
mountains of
Neom
Neom.
projects, renowned architects involved. We're currently involved in this Neom Chujina project. And the project itself, it has extremely high sustainability goals, which is achieved by the multitude of certain measures. Now, this is the so-called void facade. You can see that our facade curves in from both sides, which on both sides is then facing the rock. At the top, we have a big roof, which is covered partially with PV panels. Now, the central void area already achieves a high degree of shading. We achieve a high degree of natural airflow through this void because it is open at both ends. It's even at top of a mountain. This shows a bit of how we go into the details. So this is a typical facade system, which if you look back to this slide, the facade system has a lot of unique different angles. So getting this technically feasible, getting this built, getting the design out, getting contractors bidding for this job is quite a challenge. Now, as I mentioned before, in terms of the design of this project, it's almost half carved into the mountains. You can see on the left and right hand, we see the mountains. We then see so-called back of house at the kind of, it even includes gardens. So there's a goal that we include gardens, that we harvest crops over there, that with some salad, lettuce intentions there. And the rocks by themselves, they emit cold because it's a big, big thermal mass. Then the roof itself, it was shading, but also it includes PV panels or photovoltaic panels. So we want to generate a certain percentage of the electrical demand by ourselves within this kind of building. The vault project will be the main transportation hub for the Trojena development. So all of the cars will go there. There's a tunnel going to this building. And there's a kind of pathway down to the lake, which is also be with green and so on and so on. It's quite a unique, quite a stunning project. This is now a longitudinal section through the project. You can see the kind of scale. It is massive. So from the top, the project is actually intended to mimic the rock so that the architectural impact, so that the kind of visual impact is less. And this is a current site photo. So you see the scale of the project, it is massive. Yeah, it's not that you do a small tip, you do a big step. You can see this small construction machines and the scale of this thing. It's big. Yeah. No, it shows that, how shall I put it? It's new ideas, how we can develop more sustainable cities. And it's not starting with small steps, it's starting with the big steps. So we're starting doing something completely different. Yeah. For example, carving half a city into a mountain. Okay, another project which is currently in the press, which is called the Mukab in Riyadh, another landmark project in Saudi Arabia. The intention is to build a 400 by 400 by 400 meter cube, a box. It will be the world's biggest building, even bigger as a Pentagon. The idea is that inside this 400 by 400 by 400 meter box building, we're building another building, which is this kind of tower building, which is 330 meter height. Around this interior tower, there's a design or there's a plan of the world's biggest video projection area. Now, the whole development is the kind of center point of a whole new city development called the Mukab. The project itself, it's also one of these completely new ideas. I mean, in the end, if we talk about sustainability, how can we design a sustainable building, both in hot and cold climates? It starts with very simple things. It starts with the A to V ratio, we call it. So what is the external surface area? So what's the building envelope? For example, if we take this as a box, we have the sides, the top. Yeah, so this is the kind of envelope. And then we have the volume of the building. Yeah, and a building is more efficient the better the A to V value is. For example, the best is a ball, is a circle, a kind of box building. But if you build a flat building, it's usually pretty bad. Yeah, because you need to cool down this interior space. And the less surface area you have, the less facade and roof area you have, the easier it is, because the facades and roof, they have a poor U value. So all of the heat gain or heat loss is through your building envelope. And if you minimize the building envelope area compared to your volume of the building, then it's getting efficient. That's why, this is why, for example, like a single-story building is usually not efficient. You want to put some floors on top, because then you get a kind of box which is more efficient. It's a bit of a similar idea over here. We're creating a massive, massive interior volume, which means we also need to cool it down less because the solar heat gain is less, and also the volume or the surface area or the building envelope where the heat loss takes place or the heat gain takes place is less. Now the Mukab project,
Introducing the new
I'm going to let the video run.
horizon for Riyadh, a new icon, the Mukab, the world's first immersive experiential destination.
This is now the interior tower, the video projection area. You're going to have 4 corner towers
Another world.
and a big roof.
Step inside and it's unlike anything you've ever seen. At a scale that's unprecedented. Big enough to hold 20 Empire State Buildings. Where you and those around you enter a new reality. Transporting you to Mars one day and magical worlds the next. Where your retail experience is completely reimagined. And hospitality, leisure, and entertainment reach new levels, all in breathtaking, ever-changing environments. This is the new face of Riyadh. Experience a new horizon.
So maybe let me go back one slide to explain. So what are the technical challenges over here? First of all, we're building a building made of 4 corner towers, which are already 400 meters height. We're then building a big roof on top, which includes, I think, a racetrack, a car racetrack. We then have one facade on the exterior skin with a mashrabiyah to provide shading. We then have the inner skin, which is going to be the video projection area, which of course has to be almost smoothless. It's a question, how do we support it? What is it made of? Most like it's a membrane structure. So there's a lot of question, a lot of new design approaches that we have to take with these kind of projects. So it's quite challenging. And we're going to see how it's, yeah. Now going on to some projects that currently on site. We're currently the lead consultant for the Russell Tower in Dubai. So coming to a bit more traditional, or more or less traditional design. This tower is going to be the world's tallest tower using a ceramic facade, including terracotta. You know, terracotta, it's a kind of, it's a very old traditional material, like porcelain, invented by the Chinese ages ago. And this is going to be a cladding for the exterior sunshade elements on this tower. Talking about the challenges, this is one of our first, or one of the, not first, but one of the projects that were fully developed in 3D, together with the architects from the studio. We spent quite a lot of time on designing the right amount of exterior solar shading in combination with the glass, which has a solar control coating on the glass. So it's a kind of combining measures to reduce the solar heat gain, which is the main factor of cooling loads in the Middle East. I want to go on to some other projects that we did over the last years. We've been the lead consultant for all of the shading structures for the Expo 2020 in Dubai. So when I saw back, we've been the engineers, but also the architects for this so-called, for these retractable shades, for so-called flying bird shades, and also for some green, so kind of natural plant shading. As I said before, I mean, a bit of similar idea as for our project in Riyadh, with a different approach. Again, for the Expo, you have a lot of these pavilion buildings and people walk between the buildings. So again, it was a major task to create a comfortable outdoor environment, a thermal comfort for the people walking between the kind of pavilions. At the same time, there was a clear intention by the client that during night times, you want to see the stars. So we had to design something that's active, where the shading can be open or closed. And this is the design that we came up. You can see here the bit of the scale. So the white areas here, I think you can't see the laser on the screen. You can see all of the white is all the shading membranes. And all of the kind of dots are the kind of buildings. So it's a massive scale. It's a huge development. It's an expo. And all of the shades are retractable. So during night times, they were then closed or partially opened with light on. In terms of design of these, I have one video from Professor Werner Sobek.
That we have to reduce dramatically the emissions. The announcement is to reduce CO2, greenhouse gas emissions, within 10 years by 55%, which is something different to save 55% of energy consumption. This is even more difficult to be achieved. Everyone underwrites that, but nobody really makes clear to himself what that means, because if we are not capable to change the technologies we use to produce the materials, to build the buildings, to run the buildings, and to demolish them, if we are not, then in 10 years we are allowed to build only 45% of the amount we are actually building. Means half of us is becoming unemployed. Standing in front of a problem which says, okay, either you change everything or you cannot build in the way you build nowadays, will urge this interdisciplinary process that people start talking to each other and say, either we invent something or we are lost.
Now, talking about sustainability is also the amount of material that we use. And to create shading, for example, you can do this kind of shading as a concrete slab. But what's much more efficient is that we say we're going to minimize the design, we do a minimalistic approach, and we save material. Now, these shading fabrics, they're only 2 or 3 millimeter thin. Yeah. So in terms of material that we use, in terms of weight, is almost nothing. Yeah. We then utilize the material in a way that we can let it sag down, so using a tensile structure. So the fabrics are hanging down. The whole system has actually wind sensors, so Of course, in case of strong winds, the fabrics have to retract, so they're getting protected from the strong wind. At the same time, what you can see over here is the orientation of the fibers. And this is now the closed position. And now talking about the orientation of these fibers, we collaborated with a company in Italy on the design of these fabrics. And this is the thing, and this also when we look at humans learning from nature, if you take a section through a human bone, the human, also animals, they're so efficient that your body, that the nature itself, it orientates the material in the direction of the main stresses, mainly tensile and compressive stresses. So nature shows us, and on the left hand side is a kind of section through a bone, and on the right hand side it's a kind of finite element, or it shows a kind of lines of stress pattern of compression and tension. And a similar approach is a kind of going back to these fabrics. So we have the main points where the fabrics hang from the steel frame on tracks. Yeah? From these kind of points, we know these points are the points of stress concentration, and then we orientate the fibers in a direction to the next support point. Yeah? So we're designing a fabric that is perfectly designed for minimalistic material. And at the same time, it gets an architectural quality because we are kind of visualizing the main stress directions, which a lot of people say it looks good. I mean, I'm not an architect, but hopefully a lot of you will share my point of view. Now, going on about the technology, of course, we had to design all of the tracks, all of the mechanical equipment, all the motors, the rails, the gear, and so on and so on. The expo took a bit longer than expected because of COVID. It started late, it was running longer, and these fabrics are still in operation nowadays. They were designed as a temporary structure. Now they're running since, I think, 3 years now, almost. So we're quite happy of the projects, worked out really well, and people tend to like it. This shows a video. It's a bit of fast motion, how the fabric retracts and gives view, a clear view to the sky. Now talking about fabrics itself, and maybe this is a kind of bit of future trend, what we see, that we will build more with lightweight translucent materials in the future. Why? Because we want to save material. We want to go to new shapes. I mean, we see the architecture goes to more complex curved geometries. If you want to create curved geometries with traditional materials like flat aluminum panels, concrete, it is really difficult. Fabrics, you can easily stretch fabrics in the way you want. So this is ThyssenKrupp test tower. So this is an elevator test tower, which is the world's tallest fabric facade built so far. And in the end, it's quite a boring building because it is in the end just a concrete core with test elevators, and we had to clad it in a nice way. Otherwise, I think the local government wouldn't have accepted this tower. But it shows a bit of the kind of beauty of this material. In the summer and the winter, it picks up the light, picks up the shadow. It's even translucent, so if you look against the sun, you can see through the fabric. And you know, this whole design with fabrics, it's amazing, because it gives you the opportunity to create something that's translucent, that could also be permeable. And the whole idea of permeable systems, so systems that let air pass through, provide shading, provide privacy, ideally also has a certain thermal performance. So this slide shows some kind of research, because we are closely collaborating with the University of Stuttgart, with the ELAC. So this is currently a research project by the ELAC. It's about a kind of filament, I would call it. It's a lightweight facade systems, which uses a kind of microfibers in a kind of mesh with a certain density. And then you spray water, or you let water run through the small fibers from top to bottom. At the same time, if there's a strong rain, the system can harvest the rain. So there are different layers of the system. And I think the next slide shows the kind of main principle. So on the left-hand side, you see water drop hitting a glass surface. So the water drop kind of explodes and bounces back with a lot of small kind of small water drops, a kind of mist that goes away from the surface of the glass. On the right-hand side, you see the water drop hitting a microfiber. And you see it almost passes through the microfiber. It's getting kind of dissolved. And the same system is a bit similar to what I've been shown previously with this Al-Mishra canopy in Riyadh, with these wind towers where I had water spray system. It's about evaporative cooling. So we're using just water to cool air down. Yeah. And it's this kind of system, bit of similar, but we're not using mechanical system. We're just using water, which runs down on these microfibers. So this is kind of close-up macro photo of these microfibers. They're extremely small. The tiny little water drops start sticking to these microfibers. Yeah. So you can let this water run onto the microfibers, and they easily evolve into the air. So you're getting evaporative cooling by the natural airflow through this open material. Yeah. This shows some current testing on the right-hand side. You can see on the top right corner, this shows the top, actually this shows the drop of temperature due to the system. And you can see the green arrow is about 25 degrees Celsius and the red arrow is about 35. So on the right-hand side, it is the whole system when it's dry. So no water was running on it on the top. On the left-hand side is a wet state. So you can see that we're able to cool down the air by about 10 degrees Celsius by the relatively simple system, by just using water and natural airflow. No electricity, no compressor, no mechanical system, quite a simple system. And this is a kind of way forward. It's, it might be a combination that our future will be a combination of very complex systems, as on NEOM, or, but also maybe very simplistic systems, like these ones. It's about, getting the ideas out there, doing the testing. And, all of this starts with the understanding of the physical principles, of the understanding how can we make this world kind of more comfortable for human beings, and how does a human being work, yeah? This brings me to my next topic of my presentation, which I'm currently researching into quite a lot. It's about human-centric design. I mean, most of the slides that I've shown before was human-centric, yes. But now it's about light, yeah? You can see this is a photo, I think, from 1920 in the UK, where babies were put out in the sun. Why did they put babies on the sun? Because they figured out if a human being lacks daylight, they're getting sick, yeah? And light, there's a lot of things about light. Natural sunlight, artificial light, treated with ultraviolet light. I'm going to go through this relatively quickly. And I'm going to explain you later on how this, or what this has to do with architecture and what about facades. Because this is quite an important topic that we have to understand when we're talking about facade system and buildings. Now, when we talk about light, our human eye can only see a certain wavelength, certain spectrum of the light, or of the spectrum coming from the sun. It starts all the way on the left from the gamma rays, X-rays, ultraviolet, then the blue spectrum, the green, orange, and the red spectrum. Then we get the long wave infrared spectrum. And the long wave infrared spectrum is usually the kind of radiant heat, the long wave radiant heat. So people in the past already knew about this thing, about human and light. You had kind of light baths, also 1934. People, they go to a beach, I mean, from cold climates. People fly to Spain, and then they undress and they lay down. And after 1 week on the beach, they feel good. Yeah. Why? Why do people feel good? Why do we feel good after sunbath? Because it's about light. And there are two different things about light. And these are soldiers during Second World War from the Royal Navy. These were soldiers in a submarine. And they already back in the days figured out that the lack of light was making the soldiers sick, but also aggressive. Yeah? And the submarine is not good if people are aggressive. So the soldiers were put under sunlight, under artificial light, to compensate for the lack of light in the submarine. These were the kind of work environments in the 1970s when the big office buildings start, the big office spaces start. And about this kind of time, or maybe 1980s, 1990s, the new world of sick building syndrome started, of human beings getting sick because the environment where they are inside the building, it's not healthy. It's either because there was not proper light, there was no proper air, the air conditioning wasn't right, or the lack of natural light. And this photo shows, I mean, the people had a lot of light by these light bulbs, but it was not the right quality of light. This is why nowadays we want to do a lot of glass architecture, because natural daylight. And to understand what is natural daylight and what we have to consider nowadays, and this is also a bit of Because we have on one side, we have sustainable design. So for example, our glass technology, and I'll go into this a bit later, goes into the design of glass panels in a way that will reduce the solar heat gain or heat loss to enhance the U value and so on. But this then, to a certain extent, starts contradicting with what we need as a human being. And this is a very interesting topic, and I think you need to see it from both sides. Now, let me go on about light and human beings. So this is a map of the United States because they have good statistical data. So on the left-hand side, we see the percentage of medication against depression and anxiety. So people are getting depressive. And this is the percentage between 6% and maybe 10 or 9%. And the states in the United States with the light blue are the lowest percentage. So, which is like California and Texas, only 6% of the total population get description for against kind of depression. Now, on the right-hand side, we see a map with the sunlight exposure for a day in August. You can see that, again, California, Texas are the states with the highest amount of sunlight. So there's a clear correlation between sunlight and depression. Yeah, and this is quite interesting. I mean, it does not mean that we all need to move to Spain or some very sunny country or Dubai. But, it gives us a kind of question mark about us, what we do. And, we are all architects or building designers and engineers, and we're designing buildings. But we need to design the building for the human beings. And we as a human being, we're different to what the human being has been in the past. Now, we human beings, all of us, we became an indoor species. We are an indoor species. We're spending 87% of our time indoors, inside buildings, 87%, about then 6% in vehicles, and only 7% really exposed outside. Yeah. So the right-hand side, so the kind of graphs that is so, it means that we're only 13%, including sitting in cars, we're only 13% outside. Then about 60% of our time we're inside buildings, exposed to natural sunlight coming through glass, coming through our windows. And then 28% of our time we're exposed to artificial light from light bulbs. And this shows the kind of importance of the whole topic. And especially since COVID, the world is getting more depressive, as a matter of fact. So what do we need to do, or what do we need to consider? Yeah. Now, human beings evolved over millions of years. Yeah. So we evolved as a human being under the exposure of the full solar spectrum of the sun. Yeah. Then for the artificial light, human beings started to have candles. And I know it's not really about architecture, but you're going to see, I'm going to close the circle later on, how it comes back to our architecture that we do nowadays. So on the left-hand side, you can see before like 1960, it was mainly light coming through windows. And on the right-hand side, we see the transmittance through glass panels. Yeah. So what is the spectral transmittance through the glass that we had? And this is a current very hot research topic that even we as one of currently collaborate with a company called Guardian Glass on developing coatings on glass that are on one hand sustainable, but on the other hand also take into account what we need as a human being, what kind of spectral data we need, what kind of light we need. Okay, let's go through this relatively quickly. So the glass in the past with just very simple clear glass. So on the very top, you see the sun's spectral emittance. So what is the sun sending out? And there's a peak in the visible spectrum between 380 and about 780 nanometer wavelength. So this is what the human eye can see. And why can we see this? Because this is a peak of the spectrum that the sun emits. And our human eyes evolved to be most sensitive in this spectrum because this is the maximum what the sun gives us. So the human being adapted to the sun. Yeah. Now, is the glass adapting to the sun as we did as a human being for the sun? This is a question mark. You can see a simple clear glass that we had in the past. It had a more or less horizontal kind of constant transmittance of the whole solar spectrum, including the long wave infrared heat. Yeah. Now, when so-called solar control coatings were developed, these coatings get the U value down or get the solar heat gain down in a way that they reflect the long wave infrared radiation back to the outside, which is then seen on the bottom right corner that the infrared transmittance is pushed down. Yeah. Now, going on to all of the evolvement from all of the coatings, from the single silver, double silver, and the very modern triple silver coatings that we have nowadays, it's about that our glass transmits only the spectrum of the solar that's visible to the human eye. So all of things on the left-hand side, which is like the ultraviolet, all of the spectrum on the right-hand side, which is the long-wave radiant heat, is completely filtered out. Yeah. So we're the human being, we're getting nowadays through our glass panels, through the modern glass panels, no longer a natural daylight, it's a filtered daylight. And we can only see, I mean, we cannot see it because it's outside our visible spectrum. This is quite important to note, because at the same time, says the sustainability and the energy saving pushed us also to use different light sources for the artificial light. So at the top right, you see a candle, yeah? And the candle emits light in the same way or similar way as the sun by heat, yeah? So the flame, and you can see the emittance of this candle is a lot of infrared heat, it's a lot of heat, and only a small portion of the visible spectrum. Then below, starting from the 1930s, our traditional light bulb, yeah, has an emittance, you can see in the middle on the right-hand side, which is a bit more to the infrared spectrum, and then also a bit of the visible spectrum. This is why the traditional light bulbs look a bit yellowish, because it's more to the red side of the spectrum, not to the blue. What we have nowadays at the bottom right, because if we want to cut back the energy consumption of our light sources, we're using LED bulbs, yeah? And these LED bulbs, they emit only the visible spectrum, nothing else, yeah? And if you go to IKEA and buy these light bulbs, you can choose between the warm white and the cold white. And you can see this is a kind of peak on the left, which is the peak in emittance in the blue spectrum. This makes the LED bulbs bluish, but a lot of people like them more yellowish or the reddish because it feels more comfy. So maybe stay with the slide. What shows you that what kind of light do we get? So we are spending 87% of our time indoors. But what kind of light do we get? Through our glass, it's a filtered light. From our light bulbs, LED, it's also not the full spectrum. What is doing this with us as a human being? We don't know. It's a big experiment. Talk about sunbath and the spectrum. Why do people do a sunbath? Would you do a sunbath under LED bulbs? Would it be nice and comfy? LED bulbs? No. Because you are doing a sunbath because you want to feel the radiant heat, the long wave infrared radiation. Because on the bottom left, you see the penetration depth of the wavelength into the human skin. Yeah? And only the infrared radiation penetrates into the skin. Yeah? So you feel better after 1 week in Spain because you are exposing your whole body to the long wave radiant, to this infrared and the long wave radiant solar radiation. Now, going on about light is also about the vitamin D production, and it's also the exposure to light helps your body to produce vitamin D. Going on, this whole thing, the latest research in medicine shows, for example, a treatment against cancer with a certain red light spectrum, about 670 nanometer wavelength onto the skull of your head. Another thing is about light, and this brings me from the infrared spectrum to the blue light spectrum. And this is currently also the research topic we're doing with Guardian Glass about developing new glass that is more focused on human beings. This is a newborn baby. Maybe a lot of your kids might have had it. So the lever of a baby, which is supposed to clean the blood from all of the stuff, that's not good. With a lot of babies, it is not properly working yet. So these babies are put into this kind of chamber with blue light. This blue light with 460 nanometer wavelength, this helps that the skin is doing a blood cleaning function. Yeah. And a lot of babies do that, and it's well known they need this blue light for a couple of months, and then it's done, then it's fine. Then the lever takes over and cleans the blood. But it shows the influence that light has on our human being, on our body. Yeah. Going on from the light, This is currently a research project with the ELAC. It's about the light emittance fabric, where we can then emit light in wavelengths that we want to emit. But let me go on talking about the blue light. And this topic is, you want to wake up in the morning, all of us. And how do we wake up? We need light. But what kind of light do we need? We need the blue light. You know, the sun on Earth, naturally in the morning, you have a more bluish light. In the afternoon, close to the sunset, the light is getting more red, more yellowish. Yeah? So in the morning, we need blue light to wake up. But in the afternoon, we should no longer be exposed to blue light, because otherwise we're not falling asleep. Yeah? And this is a 400 and this is actually the 490 nanometer wavelength, which is important for the so-called circadian rhythm of the human being. Yeah? So for the day-night rhythm of the human being, we need this blue light spectrum. And this is also part of the latest research and the draft DIN standard, that we now start classifying glass panels not only for the visible light transmittance. We classify glass panels for the so-called melanopic light transmittance. So melanopic is a wavelength, or the kind of range, that is important for the circadian rhythm of the human being, around this 400 nanometer wavelength. And I think I have a slide later on, but talking about this kind of the blue light spectrum, I think all of you have cell phones, either iPhones or Apples or Samsung, and all of your phones have a night mode or a kind of blue light filter. And this is exactly doing this. So when you switch it on, your screen is getting more yellowish. So the blue light is filtered out, and it's only done in the afternoon because you want to fall asleep. Yeah. So it's a well-known phenomenon. Now, talking about the circadian rhythm and this blue light spectrum, this starts with the selection of the glass that has a high melanopic transmittance, so the high transmittance in the blue light spectrum. For example, if we would choose glass that has no transmittance in the blue light spectrum, you're not waking up. I mean, you would see sunlight, but you're getting depressive because you're not getting this, what you need to wake up. This then goes into the latest research about human-centric design as a holistic approach. So how do we design, mainly from the facade design and also from the interior design of a building of rooms for the human being? It starts that we select the right glass, that we're getting enough daylight coming through the glass, but this also continues that we're selecting the right wall paints, colors. Yeah. So what is then reflecting your light properly? And this was researched by a university, I think, in Czechoslovakia. It shows the spectral reflectance of different colors, of different wall colors. And of course, white is very good. A light blue is also very good, but everything dark is bad because it kind of absorbs the blue light spectrum. Like this black walls over here for getting awake in the morning, it's not good. And this then goes further on that you say, okay, you can see this kind of red dashed line. This is the melanopic wavelength. And you can see what kind of colors ideal in reflecting that. So when you paint your room the next time, you see what kind of colors you should choose, especially for kids. If they should wake up in the morning and go to school, choose a light blue. Maybe not for the girls, but the boys would love it, yeah. Okay, now I want to go further. What kind of colors do we like? So we know we need the light blue, which is, so the light blue is about 419 meter wide. So on the right-hand side, we see the wavelength, and on the left-hand side, the color, yeah? This 490 nanometer wavelength is a kind of very light blue. If we go a little bit to like 10, 20 nanometer wavelengths above to about 500 nanometer, this is a light green. And usually what do people like? If you look out of the window, ideally we see a blue sky, light blue, and we see green plants, green trees. This is what we like. Yeah? And this goes a bit back to what we want to see, what our eyes perceive. And this comes to also to kind of architecture. This comes to kind of point where we then said, okay, we like the light blue and the bright green. How does it revolve, or how does it reflect into our cities and also into the property market? So this is Central Park, New York. So So for all of the apartments facing the park with park view, you pay a premium that double or triple the price of non-park view. Yeah. So this shows that people want to have the vision, they want to see the green, and also the reflectance of this light green is very close to the light blue, what we like, what we need. Yeah. And this spins a bit further. So how can we get this park view? So let's go back. We have this park view, and then we have all of the buildings which are gray and white and grayish. And how can we come to a point where we do a more sustainable design or kind of sustainable city development, city design, that we're saying a park is no longer a park, or a building becomes a park? Yeah, and this is Kühlbogen 2 in Düsseldorf, I think currently the world's largest green building or green facade, where in the end we are bringing a park to a building. And it's not only that it's a benefit for the building itself and also for the local microclimate, because it's reducing the local heat island effect in the cities and so on. But if people buy apartments next door, they look into the green. So which means even the adjacent buildings, quite likely, their property prices go up. Yeah. So it means that quite often the green design or sustainable green design is not only for the building itself, it's even for the surrounding buildings. Now talking about Kühlbogen 2, just some technical details. Of course, we have the plants, which are usually planted in long kind of planter boxes off-site. There's studies with botanical specialists on what kind of plants you use. We did trials. You can see this is a kind of technology. It's quite often a kind of opaque roofing system, sometimes including glass panels. We then have the plants, usually bushes. We have a watering system. We have a kind of irrigation system for water supply. We have drainage with these stainless steel pipes there. Then everything is kind of pre-assembled, comes to site. So this kind of trays installed on site, and then the plants were craned into position. On this specific project, the client wanted to have plants that it's not green during the winter. You know, some plants are green. It reflects the kind of natural seasons, summer, winter. But then got installed and came down, and yeah, you can see this is like a park view, but in the end it's a building. I think it's quite a nice approach. It's about, will all of our buildings look like this? I'm not really sure. You know, in the Middle East, people ask me about this. And again, this depends about the local climate. This makes sense in Central Europe. We have a lot of water over here. In the Middle East, where there's no natural resources of water, this would not make sense. Because in the Middle East, green is usually not green. Because in the Middle East, if we have, for example, golf courses, it is water that was taken from the sea via desalination plants, and they take a lot of energy. So all of the water used in the Middle East has a high CO2 carbon footprint, whereas in Europe, it's not so. For the kind of moderate climates like in Europe, this definitely yes. Coming back to kind of light and vision and about sustainable design, you will see that nowadays sustainability or sustainable design tends to or wants to tell us we need to reduce or we should reduce the U value so the thermal performance needs to be enhanced. And this is then a bit of a kind of contradiction to designing with glass, with light, also with vision. This is Post Tower in Bonn, a project that we did with Murphy Jahn quite some years ago. It's a kind of modernistic or kind of modern glass tower building. So maybe taking the Mies van der Rohe Seagram Tower in New York, and I was working at Seagram Tower for 1.5 years. And tell me the Seagram Tower, it looks amazing from the outside, but living or working in the Seagram Tower, it's horrible. It was back in the days and still nowadays, it's a kind of listed building. It's a single glazing with a dark body tinted kind of grayish glass, which means that during the winter, and you know, New York, you get cold winters. It was freezing cold sitting next to this glass facade. And in the summer, it was burning hot because the glass heated up. So I mean, it was not even insulating glass, it was just a single layer of monolithic glass. Of course, since actually the Seagram Tower technology evolved and the glass architecture evolved. So on the Deutsche Post Tower, it's in most of the areas a double skin facade with kind of ventilation flaps so you can direct airflow through the double skin facade with solar shading and so on and so on. So it became much more energy efficient. But talking about glass architecture is also about getting light, but also getting the vision. Yeah, because human beings want to be exposed to the environment. They want to see the environment. They want to look out. And this is also what we see in the property market. Usually a lot of tenants want to have floor-to-ceiling glass. They want to have this wow view. They don't want to have, and usually tenants less like small punched window facades with a small window. But in the end, the small windows would be more energy efficient. There's no question about it. So it's a kind of bit of contradiction, a bit of tension between sustainable design and kind of design for the human being. Ideally, we can combine both of them. And I still think Deutsche Post is still an amazing project with amazing views. Now, coming on to kind of facades and kind of research, and I mentioned Deutsche Post Tower. It's a double skin facade with active ventilation flaps, meaning that we can open these flaps to direct natural airflow to the facade system to get hot air out. This is a research project with the ILEC, with the University of Stuttgart, where we take into account that our modern facade systems, why we're saying we need to make things more simplistic, but also we're putting more technology into the system, especially for double skin facade with active shading, so we have wind sensors, sunlight sensors, and so on and so on. This is an approach, and hopefully the video works, that we're using VR glass, because in the end, it's about these modern facades and also Deutsche Post Tower. It's all controlled, that the facility management system is getting smarter. So that first of all, we're getting active facade systems where the facade systems can actively react to, for example, sunlight conditions. If the sunlight hits the facade, put the shading down. And this is a system that the facility management people can later on walk through the building, and each unique facade panel has their own chip. And via VR glasses, the facility manager can log into the facade system and can check the facade system in a haptic way with the fingers for the current performance in terms of solar shading, U value, put the blinds down, for example. You can also later on check if the system has a malfunction. If there are any issues, they can start certain functions. So it's a way that we want to say that also the modern technology gets easier to use for the tenant, for the facility management. Of course, you can see at the top, it's a kind of air pressure, humidity levels, and the temperature levels. And once the facade system recognizes, for example, a very strong wind, then the active flap in the double skin facade would automatically close to prevent high wind going through the open flap. This is a kind of shading system, humidity levels, and so on. So it's a bit of a way that we want to control all of these parameters in a kind of, more kind of holistic way. Now, going on, and this comes to almost the end of my presentation. I hope I wasn't talking too much. It's about, again, about glass. And, I personally, I've been doing a lot of research into glass, about structural glass, about thermal performance, about light transmittance of glass. I've been very enthusiastic about solar transmittance and spectral transmittance of glass. It's about what is the future. I mean, we looked back into the past. Now we look into what we're doing right now, including NEOM and some amazing projects that we're currently designing. But what will be the future? And will the future be that sustainability or sustainable design will be that we're building houses underground in mud and earth and with small windows? And I think they're currently in the architecture, there are two different trends or two different paths. I think one path is getting more traditional, using like mud bricks or more traditional building materials. But the other way is a bit more using high tech, that we get this problem sorted by technology, what human beings did over the centuries. So this is the R129, which is kind of a research project that when I saw back our office was running, is currently running. So the idea is that we're just building kind of glass shell, so that in the end we are creating kind of monospace, and that this monospace lets the border between inside and outside more or less fade. You can see this kind of hull. However, to get this work, we need to take big steps in technology, which means for this kind of system, we're looking into switchable glass. So the glass has to be able to actively respond to different sun conditions. For example, if the sun is out, if the risk of overheating, need to make it very dark. If there's no sunlight on the dark winter day, it has to be very transmittent, so very open to glass. We need to be able to filter certain spectra to know what we need as a human being in the morning, the blue light. At the same time, this glass has to achieve high thermal performance requirements, so it has to be, for example, vacuum glazing to get the U value down. At the same time, it has to have a structural performance to resist all of the wind loading and so on and so on. But I think only if we take certain goals, if you say, this is where we want to be in the future, we know where we need to work on. And this is a kind of rendering of the idea where we want to go to. And we at the University of Stuttgart, you see on the bottom left, this was built already a couple of years ago by my colleague Lucio Blandini. This is a glass grid shell. So this is a big glass dome, which is only built out of glass. There's no steel, nothing else. So we're just building a glass monocoque. Yeah? The outer ring, for example, is made of titanium, because titanium has the same coefficient of thermal expansion as glass. So you're perfectly matching these two. So if you see that on the right-hand side, this is the kind of future dream, and on the left-hand side, this is where we are right now in research, I think we're not so far away, so maybe the future starts pretty soon. This brings me to the end of my presentation. So thanks, everybody. I hope you enjoyed the presentation.
So anybody who was thinking we were going to talk about joining of the facade had something different completely. And thank you very much for a very different view of what a facade is and what the future of architecture actually is. Is it sustainability from the nature point of view and CO2, or is it human-centric? Which I would agree or argue that that's where the future is, but because the future will be where the humans are.
Correct, yeah.
So thank you very much, and I'll open discussion. If this is soaking down to everybody, it's a quite different view and approach to what a facade is. Thank you.
Are there any questions? Sure, anyone?
Hi. Is it working? Yeah. Thanks for a great presentation. I think we're all enjoying. Yeah, it was quite interesting when you were talking about the whole study from like the history, the past, like how we should be exposed to the sunlight and like be outside and like enjoy natural environment. And the whole study about the transmittance of the glass, how it's actually how we receive the sunlight and what actually parts of the sunlight through the glass. And you are actually finishing the presentation with a huge glass dome. Like, can you explain a bit what's the difference with this glass that you're ending presentation with to the one that actually we are spending life like nowadays?
Yeah, I mean, okay, let me start this way. But I mean, glass is the only material, or the very few materials that we have that transmits light. At the same time, gets a building enclosure. So if we want to go to this, what we've seen over there, I mean, currently glass is a weak point in terms of thermal performance of a building. And from this, we need to get away. Yeah. And this is about evolving glass in a way that I described. So getting the U value better, getting the glass more active. I mean, nowadays we have so-called switchable glass. So the technology is slowly progressing. Maybe not as fast as a lot of people would like this to be. So this is why currently I see a lot of architecture or sustainability pushing architecture to more traditional designs, using less windows or smaller windows, using also different materials, going, for example, away from concrete, using more timber. I think maybe in the future we're going to have a mix of these approaches. Ideally, we pick the best out of everything. But this also then depends on the architectural designs. I mean, what kind of designs are we coming up with? But in terms of how can we get the glass there, I think it's still a way to go. You know, this kind of glass dome was just working structurally now, but all of the thermal still has to be resolved. I mean, this is a kind of dream that we had, just living in a kind of glass shell that is active, and we completely see all of the skies, all of the stars in the clear sky during the night. But we're not there yet. No, it still takes some time, unfortunately. Yeah.
Yeah, thank you. So do you feel that this in the end, once the really technology develops, this is going to be like, you're going to reach the point where under this glass dome, you're going to basically feel almost similar like to being outside?
Ideally, yes. I mean, we see a lot of...
Is that the goal? I mean,
this is a goal, and you know what currently is getting built today is maybe not as good as it could be. For example, some of the world's tallest buildings, or the currently world's tallest building, the Burj Khalifa, it is utilizing a glass. And I don't want to criticize the architecture, but it's a nice silver reflective appearance of the glass. But this glass has a light transmittance of only 18%, 18%. Normal glass, like we have it here, is about 70% light transmittance. So it's not a high-performing glass. It was selected by the architects for certain architectural appearance. So maybe sometimes we also need to maybe discuss with the architects, maybe choose a higher-performing glass, and maybe sometimes cut a little back how this thing looks like in terms of visual appearance, but gain more in terms of light transmittance for the human being, and also then lower solar heat gain coming through the glass. And still I see, unfortunately, a lot of architects just picking the glass that they like architecturally the most, a bit of ignoring the technical performance, which could be more sustainable and more focused on the human beings. Yeah.
thank you.
Hi, it was amazing, really. I enjoyed it. But I want to go to the beginning, very beginning of your presentation, because the house you show at the beginning was, it belonged to some prominent or well-off family, but nonetheless, even less fortunate or less rich persons or families in a village could use some of the solution from their house. I mean, they all lived in that way. Either they were wealthy or not. But some solutions you show to us are for, you know, highly developed countries. So I'm just interested how these solutions could be, you know, transmitted to more or less to all.
You know, I think it's quite simple. I mean, it's about the price of the energy, the price of gas. For example, if you need to do heating in a cold climate, if the gas prices are rocketing up, what they have been doing over the last 1 or 2 years, that at one point of time it's getting more cost effective to have a highly thermal insulation on your facades, because then you're saving heating energy. The same for the very hot countries in terms of air conditioning, cooling loads, about the kind of electricity cost, which also is going up. So also there nowadays makes sense to have a better thermal performance of your building facades. So I think for the countries that are maybe less developed, I think in the end you have to do something. Either the people will have to bear the high costs of gas for heating, or they do something about thermal insulation of the building, or the people will live like in this old farmhouse with just one stove and the wooden stove where they put wood in there, which maybe in some less developed countries this is still the case. So I think getting our buildings more sustainable, I think just the increasing price of energy and gas is pushing into the way if we want or do not want. Hope this is. I mean, I still think that there are cost-effective ways to thermally insulate your building. I mean, like rock wool is not expensive. Even less developed countries, not such a big cost factor. But yeah, I mean, I do agree that some of these very high-end approaches are maybe more applicable to certain countries or certain clients. And even in the Middle East or the so-called rich countries, only certain clients can afford a double skin facade with operable and shading, computer controlled. Not all of the clients do afford it, yes.
Okay, thanks.
Thank you.
Hello, my name is Konstantina and I'm fascinated with everything you showed us. So I have a million questions, but I will try to have only one. Maybe two. About the glass, I'm interested in some structure of the glass you're producing now, because I remember the glass in the old house of my grandmother. They have the glass with a lot of crystal inside. And percentage of the crystal made a difference of the glass and the reflecting and etc. etc. So the question is, what the structure of the glass really now, and what inside of the minerals, etc. etc. And the other question is about this, how sustainable we live now without glass walls or with glass walls. And I feel this, you mentioned, some people will go inside and not to be exposed, and some want to be exposed. So I think it is good to be both things really, because I don't want to be exposed every day to these glass facades. Sometimes I want to be in my shade and in my shell, but different type of shell, not glass shell.
Yeah.
And the question is really about these glass facades and everything. Should we really live exposed or not exposed nowadays? What is the meaning of this exposure, really? Do we really need it? In which way?
It's a good question. I mean, starting with your first question about structural performance of the glass. I mean, the old glass, it was kind of drawn glass. It was very thin glass, only small formats. The way you had this kind of small glass panels only in the past. But then a British gentleman called Mr. Pilkington invented the float bath process, so where you actually put liquid glass on liquid tin. And since then, we're able to produce a float glass, which is big pieces of flat, optically very good glass. And since then, we then started having tempered glass, so we do thermal treatment to the glass to get it stronger. And since then, we can do these big glass panels. I mean, they're like companies like Sealy from Germany. They're doing all of these Apple stores with glass panels being like 16 meters length and one piece of glass. So the glass almost disappears because it is so kind of transparent. So in terms of design, the older glass didn't have the strength of the glass that we have nowadays. But at the same time, glass became a component, a building component that was just installed by glaziers without any structural calculations. Whereas nowadays we have to do structural calculations for the glass. So we'll do glass thickness based on the wind loading, based on the impact of human beings. So the whole design became more conservative because the glass facades became an engineered product instead of a kind of just installed by craftsmen in the past. And you know, when I was a young facade engineer quite a while ago, I was using kind of laser optical tool to measure glass thicknesses, and was working in London at this time and was checking these old big storefronts of like Selfridges, of these old shops which are like 60, 70 years old. It was only like 4 millimeter float glass, so ultra thin, whereas nowadays we would use like 2x10 laminated as a safety glass. And so the whole design became a bit more conservative because I think nowadays we have higher safety requirements in terms of the standards. And I hope this answers your first question about the technical side, the structural side of the glass. So there's crystals in the glass. I'm not sure what but usually we call it nowadays an impurity in the glass, which makes the glass weaker. So you should ideally not have it. But in the past, it was maybe blown glass, but you know, yeah. About the second question about exposure to light, yeah, as I said, it's, and you know, I took a few slides out. Maybe they've been interesting because, for example, if you take plants, nowadays we have this kind of indoor farms. So nowadays we have farms that are inside a building where usually it's kind of lattice and they just have artificial light. So for plants, there's been a lot of research what kind of light they need. There's usually 3 spectral emittance or 3 kind of colors that kind of plants need. So for plants, we very well know what kind of light they need. For human beings, it's not the same. You know, we just started with the research, and just recently, you know, also one of the chairmen of a big conference called Glass Performance Days. And it's a lot of research, and just recently it was found out that the UV light, so the ultraviolet light, was found to be quite important for human beings. And this is usually the UV light that all of the shop fronts filter out, because it causes all of our colors to fade out more quickly. This is why everybody was putting films on the glass or coating on the glass to filter out the UV light. Now it was found out, as a human being, we seem to need it in any kind of way. It's the same thing, when we're designing greenhouses. So for example, greenhouses, they don't have a normal PVB interlayer for the laminated safety glass for the skylights, because the UV light is needed by the plants and also by the small animals on the plants. So all the botanical people will tell you, when you design greenhouses, use very simple, very clear glass. Don't go for modern coated glass, because this messes up the plants. So I think we're just at the start, and we are discussing with universities, with Darmstadt, a colleague of mine, with Stuttgart, because it's going to be kind of combined research, because you need to have psychologists to assess, are getting people depressive or not. You need to have medical people, biology. So it's just, the human being is a bit more tricky than a plant, because a plant, it grows or does not grow. It grows quick or less quick, but with a human being, it's not this quickly to assess, is this glass or this light making you depressive or more depressive? So I think we're just at a starting point where maybe our architecture and also glass design is then collaborating closer also with other disciplines in terms of research. It's very interesting, but I think it's nice to be at the forefront of this new topic. This is why I started to present it over here, to show the new things. But I think in the end, it's up to the human being. Some people like being outside, other people like staying inside. The society changed, that people spend more time in front of screens, iPads, computer screens. Maybe this changes also. So it's a bit depending on who you are, yeah? Some people don't like windows because it causes glare and reflection on your TV screen, yeah. It's, yeah.
But I think it's very important, this vocability of the cities on the East. You made them go outside and real outside and walk, because with these screen shadings, etc., because I was on the expo and I had this experience of sun, and I was running around and taking these shades to survive, really. Yeah. So it's very important that we can go really outside, not with a glass shell, but to feel the sun, and when we are inside, that's okay, to have a perfect glass. But that's the question, is if you are living outside, do you living under the glass shell or not? What is the difference really? What is the quality of life?
I mean, our glass shell needs to be active. For example, if we talk about cold climate like Belgrade over here, that during the winter we want to harvest the sunlight, because the sunlight gives us energy. So for example, during the winter times, we want to have a high transmittance of the solar spectrum coming through the glass, because this reduces our heating inside the building. Whereas during the summer, we want to keep this heat out. Yeah. So this is where the whole glass comes, that we need to have active facades. So active facades meaning they actively respond to the climate, which was, I think, the second of my slides showing this operable shades from this old farmhouse. Yeah. They were able to open and close the shades, which most of our buildings nowadays no longer have, unfortunately. So it's this question, did we progress or did we step back? It's, yeah.
Thank you.
Thanks.
Hello. My name is Alexander, and thank you for the lecture. I have, in a way, a question. I want to share a study that was done in 1975, 20 years after the beginning of building the new Belgrade. And after 20 years, they wanted to make a study what was happened 20 years after. And when the city was projected, there was a lot of interdisciplinary, it was a process that was interdisciplinary. There was a lot of scientists, a lot of people included in the process. And after 20 years, they had a problem that was, we are talking about the living and dwellings. It was a problem with the heat. It was a problem with separation from the nature. And it was a problem with the noise, because there was near to the highway. And the simple way, the simplest and maybe the cheapest way was to build trees in front of the highway, to build trees between the buildings. Also, the trees needed to grow like 20 years after. And the heat was there because of buildings, surrounding buildings were collecting the heat and make the radiation. Also, the technology of cooling was not at the level as now. And also there was a psychological problem, and the people that were living on the higher floors was separated from the nature above 7th floor. So the trees were covering the solution until the 7th floor. And that was in a way like indirect the question about the glass. Usually the history of architecture is developing as the technology develops. It could be one of the methods. And also the developing of the opening and the thickness of a wall. So usually I see the projects driven by technology. That is like obvious, but in a way I see it like separated from the nature. And maybe that connection, I see them enclosed, not connected. And when you were discussing about the circadian rhythm, usually some of the lectures about the circadian rhythm motivate people to go outside, because in the early morning and late in the evening, because of the blue and the red light. So again, it's the motivation about going outside, and also the idea of a glass. Usually, in my mind, is always like connecting with nature and in a way working with nature. So you can see this as like more like an open question. That's how I, in a way, see that, and how my question is: do you see the projects, your projects, separated from the nature or going in that direction?
It's a good question. I mean, if you want to bring nature into cities, it's more the kind of city development or the kind of bigger master planning of cities, which is in the end not really my profession, because I'm more a facade engineer. I mean, we're doing, but I mean, I do agree. I mean, in the end, it's about combining the two, that you put greeneries into the cities, ideally next to the buildings, or maybe onto the building facade. But I think it's not an easy, straightforward answer, because I think it depends on the local environment. If we have the space for trees, is the city already developed? So, yeah. But, coming back to this kind of human point, and what I think it's that we need to more consider how a human being works, and maybe all of us need to read a bit more. I mean, and every time we're learning more, and it's not only for architecture, also for kind of a normal life. I mean, I just read a research paper that children, that the human eye of a children, that the lens of a human eye of a children didn't age yet. So our eyes are aging. So when we're getting older, our vision is getting worse. And this blue light spectrum, this circadian rhythm, so this kind of blue light that we need to wake up, but we shouldn't get exposed to in the afternoon, the transmittance of a kid's eye for this blue light spectrum is 6 times higher compared to an adult, because on an adult, the lens of the eye already aged and it's filtering out the blue light. So if you're giving your child an iPad before going to bed, it's 6 times worse times of the blue light exposure than for an adult. So don't be surprised if your kids are not falling asleep after using iPad, because there can be a lot of things that can be coming out, things that no one knew about, and we're using all of this new technology in a way that we think is all good, but then I think we need to more often question things. Are we doing it in the right way? Are we going into the right direction? Is the technology good for us, or do we need to change the technology? So it's a kind of very I think it's going to be very interesting times because we are learning things where maybe 5 years ago we didn't think about. We thought it's all fine using all of the electronics, a very modern solar control coated glass. Whereas nowadays I got a bit more cautious because I tend to tell some architects or clients this glass will not have a natural daylight coming through. It's a more filtered light. You have the benefit of a lower solar heat gain coming through the glass, but with the downside that the light is not what nature gives us or wants to give us, or where the human being adapted to. So it's a bit of kind of an interesting thing, and I think we need to start putting more question mark behind things, think about things, and see where the future goes. Yeah.
Thank you.
Any more questions?
Seems like you left us wondering about the light we are seeing.
Sorry, I didn't want to put it like this.
So we'll be looking at the spectrum from now on. Thank you very much, Ben. This was very inspiring lecture and influential for us. Sure.
Thank you. Thank you.